password to be simply the string password, which still apparently many people do. Okay, you cannot get into the system because if somebody just types that in, a secure message will be sent to the user's phone, which you don't have as an intruder. Okay, so you can't still access the system. So it provides additional layer of protection. So this is called two-factor authentication. You have things like one-time passwords that some banks use. Okay, online merchants use third-party payment systems to protect your credit card and financial information. As you know, if you're going and shopping online at some small merchant, you don't feel comfortable giving them your credit card because you don't know what kind of system they use to store credit cards and so on. Instead, what many of these merchants do is send you off to a third party like PayPal or Amazon Payment or Google Checkout, where you have already stored your credit card and they just ask you to authenticate to that site and authorize the transaction. Okay, this prevents you from providing sensitive information to people, merchants you may not trust, and yet allow you to make payments and things like that. So there are a whole slew of these techniques that are used, whether it is web-based systems, whether it is online mail and so on. So here is a picture of a firewall which I was just talking about. So firewall is essentially a box that sits between the inside of your network and the outside of your network. Okay, so here is an internal network. This is a firewall, that's an external network. Every packet that comes in or is going out is matched against a set of rules. Okay? The rules are going to be checked, and the end result is going to be one of two things: allow this packet or deny this packet, based on the rules. So if the rules say allow the packet, then the packet is let in. The rules say deny the packet is not let in. Okay? The default firewall will have two rules. Okay? So the first rule will say all traffic from inside should be allowed to go outside. So anytime a packet is traversing from inside to outside, that rule will say let it go out. Okay? The second rule is any traffic that is coming from outside should not be let inside. Okay? So all traffic from outside is denied. Okay? So then basically if a random packet shows up at the firewall, it will be dropped, it will not be let inside. Okay? So those are two default rules that any firewall will. If you actually have a home router with a Wi-Fi box or some router of some sort, it will have a built-in firewall. Those are the two default rules that are configured. Then you can add whatever additional rules you want. You can say, I want to open up all packets that come from outside should be allowed to access such and such port. If you add that rule, if a packet comes in trying to access that port, you will let it in. Okay? And so on and so forth. Is that clear? So we spent a little bit of time talking about secure email as an application that brings all of these concepts that we talked about together. It's just a good use case. So the goal here is that you, rather than sending your email as you normally do in plain text form, which neither gives you any security nor confidentiality or anything like that, we want to develop a secure version of email that will give us 4 properties. First one is secrecy. Secrecy means if I send an email message to my friend, only that person should be able to read it. Nobody else who actually sees it in transit should be able to figure out what is inside that email message. That says secrecy. Okay. Second is sender authentication. Okay. If I receive an email from someone, if I receive an email from my friend, how do I know it came from them? Because email is, as you know, you get spam, people can force sender addresses and all of that. So if you get a message, a sensitive message, let's say from your bank, okay, saying your account has been compromised or something, and then do something to it, how do you know that is not a phishing message but an actual message? So you want to do sender authentication. Okay. You want to do message integrity, which says that nobody has altered this message in transit. Okay. That it's not like when the message at the mail server got hacked and the intruder is sitting and actively modifying the text of the message. So you want a sender integrity, and you want receiver authentication, which essentially says only that person should be able to read it. Okay, no one else. Okay. Is that clear what the goals are? Okay, so now as it turns out, the concepts that we talked about earlier, okay, all of those can be simply used to implement secure email. So we are going to build it one step at a time. Okay. First we'll look at secrecy. How do you send a secure secret message email message to someone. You encrypt the message. You already know how to do that. You can simply use, if Alice wants to send a message to Bob, Alice is going to get Bob's public key, okay, and simply encrypt the message using Bob's public key and send off that message. Since only Bob has his private key, only Bob can decrypt the message. No one else who intercepts his message will know what is in the message. They can't decrypt it. Okay. Very straightforward. Okay. Now, as I also said, using public keys to encrypt messages is actually very expensive. Okay, so if you just do that, that is not going to, your machine is going to sit and spin while you are trying to read your email. It's going to take a long time for it to actually show you what's in the message. So you want to use that idea, but in a more efficient way. So what Alice will actually do is not encrypted with Bob's public key, but Alice will generate a random symmetric key K, okay, which is smaller than the public key and hence more efficient. And she will encrypt the message with K. Okay? And then you have to send the encrypted message, but Bob doesn't know the key yet. Okay? So you are going to send both the message and the key. So what you are going to do is you are going to take the encrypted version, okay, which is the email, the encrypted email, and then you are going to take the key and then encrypt that with Bob's public key, which you know. So your email is going to have two parts. It will have the encrypted message that is encrypted with the symmetric key, and then the key is going to be included in the email, but the key is encrypted with Bob's public key. So what this ensures is only Bob can first of all extract this key. Only Bob knows the private key. Okay. So if only Bob can extract the key, it follows that only Bob can decrypt the message that is encrypted with that. Okay. So this is basically how you are going to send a secure message. This is sort of version 1, but it's not efficient. This is version 2, which is going to be more efficient. So every time you want to send a secure message, your main client, not you, your main client will generate a key. Okay. It will then encrypt whatever message text you have typed with the key. It will take the key, it will take Bob's public key, which is presumably available to your main client. It will encrypt the key with Bob's public key and send both of them. So Bob's mail client, not Bob, but Bob's mail client will then take Bob's private key and extract the key first, and then use the key to decrypt the message. And then you can read it in text as it was saying. Okay. So this only gives us one property so far, which is secrecy. Yeah, we have wanted 4 of those properties, so we have to still work to make this better. Okay, so second is we want authentication and integrity. Okay, first we will try to solve that without the secrecy part. So how do you ensure that Alice has sent this message, okay, not someone else? And how do you ensure that the message was not altered in transit? Okay, so the way you are going to do this, we are going to use the hash function. Okay, so essentially we will ask Alice to sign the message. Okay, so saying if I want to be sure that this message came from Alice, you basically sign the message. So all that Alice is going to do is take message M, apply a hash function. Okay, so now you have a hashed version of your email message. You are simply going to use your private key and sign it. Okay. So now if you send the message and the signed version of the hash, Bob can figure out that Alice has sent the message because she signed the message. You can verify that she signed the message by taking M and reconstructing the hash, because the hash function is known. So you will construct H of M from M. You will take Alice's public key and extract H of M from here, and you will compare the two. The two match. It will tell you that number 1, Alice signed the message, and also second, that nobody has altered the message. Because if the message is altered, what comes to your mail client is M prime, not M that was sent. The hash of M prime will not match what is in the signature. Okay, so you know that somebody tampered with the message. Okay, so this is giving us authentication and integrity, but this is not going secure. As you see, your email client is sending M unencrypted, but is going to send a signature. This you may often see. You may get a random email where the message is in plain text, but there is a signed version of the message as an attachment. So this, if your mail client has the person's public key, you can verify that that person sent it and the message hasn't actually been modified. Okay, this is unencrypted email, but signatures, digitally signed emails. Okay. So now you can take both of the things, which is the secrecy part and this, and combine the two. That is going to allow you to send encrypted email and also signed email. So here you are signing but not encrypting. In the previous case you are encrypting but not signing. So that's what is shown here. Okay, so the way you are going to do is that you want to send an email message M. Okay. Your mail client is going to first generate a hash of M. Okay. And then your mail client is going to sign it with your private key. Okay. In this case, if Alice is the sender, the mail client is signing the hash of M with Alice's private key. That's the signature. Okay. So then you are going to take the text of the message M and the signature. Okay. You will take that, we'll call that combined message M prime. Now we will actually encrypt M prime. And we will use the previous technique. First your mail client will generate a symmetric key K and you will encrypt M prime with K. Okay, so now you have taken the email and the signature, you encrypted it. Okay. And then what you are going to do is, since the key also has to be sent, you are going to take Bob's public key and encrypt the key itself. Okay. And at that point you are going to send K of M, which is that, and the key. Yeah, when Bob's mail client receives this, they are going to first take their private key and extract the key. Okay? And once you have the key, you are going to apply it to the encrypted version of the email and decrypt the email. So from the email you are going to get M prime back. M prime is essentially the message of the email and the signature. Okay? And then you are going to verify that the signature actually is from Alice. So then you also know the email came from Alice. Okay, so if you put all of that together, you have secure email that's going to give you also the authentication property that only you can. And last but not least, it should be clear that somebody else who gets this cannot actually figure any of this out, because only Bob can first of all even extract the key. Okay, because it's signed with, or not signed, but encrypted with Bob's public key. Only Bob knows the private key, so only Bob can even see this message. No one else can see the message. So there are mail clients that actually do all of this. It requires you to exchange keys and certificates and whatnot first, and then you can actually send secure email. It's very clunky because you have to ensure that the keys are there and all of that, so it is not taken off. But most of the mail clients actually support it. Thunderbird or Apple Mail and all of them actually support sending secure email in this fashion. Any questions here? So this should give you some sense of how you can take some of what I was talking about and build a secure thing. And I'm going to show you the same thing as SSL, and then we will stop. Okay. So we talked about secure email. So next is, how does a web browser set up a secure connection to a server? Yeah, this is, so that is whenever you type HTTPS : some URL, first thing your browser is going to do is set up a secure connection to the server. So how is that going to work? So you will actually see how that works. So here is essentially your SSL protocol. Your browser is going to first send a message to the server saying, send me your SSL version number and references and so on. Typically a server will say SSL version 2, which is the latest version. Okay. And then the server is going to send to the browser, okay, a certificate. Okay. A certificate is essentially the server's public key, okay, but signed by a trusted third party. Okay, because for anything to happen, you first need to know server's public key. If I contact CNN in encryptor, I need to know CNN's public key. How do I get it? Okay. We are going to have the server send it to us. Okay. But because key distribution is a problem, the key is sent to us encrypted as a certificate where it's signed by a trusted third party. And as it turns out, your browser will actually have the trusted third party's public key so that you can verify that the key is accurate. It's not tampered. So the certificate will say this server is CNN, here is the CNN's public key. Because in fact, anytime you have an HTTPS connection with that green lock sign, if you click on that lock sign, it will show you a certificate, and you can actually say examine certificate. It will say who is a trusted third party that signed it. There are certificate issuing entities. You actually have to pay them and they will issue a certificate to you. They verify your identity so they don't give certificates willy-nilly. You can't go and claim I'm CNN, give me a certificate. Okay, they will actually verify that you are who you claim to be and then give you a certificate. So your browser will actually just get that certificate, okay, and it will verify that the server is who it claims to be, and you'll also get the public key from the certificate. Okay. And so the signatures are from what are called certification authorities. There is VeriSign and a whole bunch of them. You can go and look in the preferences web browser. It will say, I recognize the following certification authority. These are the trusted third parties that your browser trusts. Okay, that's already built into your browser. So you will use the CA, you will verify the certificate and whatnot. And at that point, your browser is going to generate a session key K. Okay. It will encrypt K with the server's public key that came inside the certificate. Okay, because you could extract it from the certificate. It was signed by the CA. The CA's public key is already built into the browser, so you can extract the server's public key. So you generate a session key, you sign it with the server's public key. Okay, so then you are going to send a message saying all future messages are going to be encrypted. Here's the key. Okay, and then you send off the key to the server. So only the server can extract the key using their private key. Okay, and then the server is going to tell the browser all future messages are encrypted. Send the key back. Okay, you can also exchange nonces in this case if you want, okay, in certain version. But at that point, a secure connection has been set up, and all subsequent communications will use a session key to encrypt. Okay, so this is essentially how SSL is going to work. That's right. Any questions here? Out of time, we are going to skip electronic payments and all of that. I'm going to just wrap up here. So we are done with the class. Okay, so in the very last lecture, these are all the topics we covered. We started with processes, threads, we did scheduling, virtualization, migration. We spent some time on communication and naming. A bulk of the time is spent on canonical problems, leader election, transactions, and all of that. We did some fault tolerance, consistency, applications. In the last few classes, we looked at file systems. Last time we did middleware and set of special topics, data centers, and computing, cloud computing. We didn't actually get to multi-media, that was planned, but we came back in interest of it. So that is it as far as the course is concerned. As I already mentioned, as far as the final exam is concerned, the latter part of this is going to be emphasized more. Okay, the early part is still covered in the final, but it will be emphasized less because the midterm already tested all of you on that. Okay, so if you have any questions about any aspect of the class, you can come talk to me today. If you have questions during the final, send me email. I'll try to clarify the question and so on. Okay. So I'm hoping that you have gotten something out of this course. Give me some feedback in the course evaluation, which I'm hoping to use next time. But if you have any other feedback, questions or anything like that, come and see me. Okay. So let's stop here. We will end the course here, and I hope that you will have a good final exam, finish the lab, and then have a good summer. Okay.